Welcome back. We are going to go over the practice problems that go with the geometric mean pink foldable. So if you've already tried those problems on your own, great. Otherwise, I will be going through all of them. So first, we're just going to start by looking at how to find the geometric mean of two numbers. So they ask us to find the geometric mean between 9 and 15. So how we're going to set this up is we're going to put the smaller number, 9, over x, is equal to x over the greater number. So now to solve for x, we're just going to cross multiply. So this tells us that x squared is equal to 9 times 15. And this tells us that x is going to be equal to the square root of 135, because 9 times 15 is 135. And then if we were to plug that into our calculator, that would tell us that x is approximately 11.6. So finding the geometric mean of two numbers is pretty straightforward. You could also just know that when we're finding the geometric mean, you're just going to take the square root of the two numbers they give us multiplied together. So I could have just directly taken the square root of 9 times 15 and gotten the same thing. So now here they give us a triangle and they ask us to solve for A, C, and F. So A, C, and F. So we're going to start by looking at F, because this is our altitude. So we could set this up as 24 over F is equal to F over 6. So remember, when we're finding the geometric mean, we want our variable to be opposite of each other in the proportion that we set up, so that when we multiply them together, we have our variable squared. And then we have to look at our triangle to know how to set up that proportion. So we have 24 over F. So when we look at 24 over F, we're looking at triangle ABD. So then we know that on the triangle BDC, that's going to be proportional to F over 6. So now, solving that out, we have F squared equals 6 times 24. 6 times 24 is 144. When we take the square root of 144, that gives us F equals 12. So we've solved for F. Now we're going to solve for C. And we can do this using the Pythagorean theorem. That makes this really easy. So if we look at C, we know the length of one side and we know the length of the shorter side. So C is our hypotenuse in this situation, because we're looking at triangle ABD. So if A is a side length, or if 24 is a side length, and if F is a side length, we know that F is equal to 12. So we're going to set this up as 12 squared plus 24 squared equals our hypotenuse, C squared. 24 squared is 576. F squared, or 24 squared, is 144. That's equal to C squared. These two numbers added together equal 720. When we take the square root of that, if we want to be precise, we can leave it as a square root of 720, or that's going to give us approximately 26.8. So now finally, let's solve for A. So now we know, if we look at the big triangle ABC, we have the length of our hypotenuse and the length of side C, and we're trying to find the length of this side A. So plugging this into the Pythagorean theorem, we have a squared, what we're trying to solve, plus b squared, which in this case is c, and c is, if we're going to be precise, let's use just the square root of 720, and that's squared equals our hypotenuse. So we have to look at these added together. So 24 plus 6 gives us 30 squared. So now we have a squared plus the square of the square root of 720 is just 720, and 30 squared is 900. We have to subtract 720, which is going to give us 180. That's equal to a squared. We can take the square root of that. Again, if we're just going to be exact and not simplified, that gives us a square root of 180. But when we plug that into our calculator, that's going to be approximately 13.4. Our next problem is really similar. So we're going to start by solving for x this time. So we have x over 16. 16 is our altitude here. Is going to be equal to 16 over 8. It's the exact same setup as the problem before, except this time our variable is where the 24 was. So now cross multiply, we get 8x is equal to 16 squared. 16 squared is 256. Divide by 8. We get x equals 32. Now let's solve for c. So we have one side length is 16. So again, we're going to use Pythagorean theorem. So 16 squared plus 32 squared, our other side length, is going to equal c squared. 16 squared plus 32 squared, when we plug that in, is going to give us 1,280. We take the square root of 1,280, that's going to give us c, or approximately 35.78. So now that we have c, we just have to solve for a. So here, a is a side length or leg of this triangle ABC. So we're trying to find this leg. We know c is the square root of 1,280, and we know that this hypotenuse length is 40. So again, using the Pythagorean theorem, we have a squared plus 1,280, the square root of that, squared, and that's going to be equal to 40 squared. We have a squared plus, this is just going to be 1,280. 40 squared is 1,600. Subtract 1,280. We get a squared equals 320. So a is going to equal the square root of 320, or a is approximately 17.89. So you might ask, why am I plugging in the square root of the number into the Pythagorean theorem and not the approximate value? Well, when we round and approximate, our answer is not going to be as precise as it should be. So I might come out with kind of a wonky number, I might be off slightly when I plug in the approximated value. So last problem. James is at a museum and wants to determine the height of the statue. He positions himself so there's a 90-degree angle from his line of sight to the top and bottom of the statue. Find the statue's height. So first, we know that James is 6 foot 2 inches tall, and he's 8 feet and 10 inches away from the statue. So first, we're going to convert all of our values to inches. It's always important to make sure that we are working in the same units. So here, I would just take 6 times 12 and add 2 inches, and then 8 feet times 12 plus 10. So when I do that, this is going to be 106 inches, and this is going to be 74 inches. And this shape here is a rectangle, so we know his line of sight is 106 inches long, and the height over here is 74 inches. So now, using geometric mean, we're going to find this height right here, because we already know this height is 74 inches. So to find the total height of the statue, we want to find this value. So that tells us that x over the altitude, which is 106, is equal to this altitude, 106, over 74. Because if we're looking at this triangle and this triangle, x corresponds with the altitude, and the altitude corresponds with this. Now we're going to cross multiply. We have 106 squared is equal to 74x. This is 11,236 equal to 74x. I keep working up here. So if we divide 11,236 by 74, that's going to give us that x is approximately 151.84 inches. And then remember, that just gave us the height of this portion here. So to find the total height of the statue, we have to add in this. So we're going to add 74 inches. That's going to give us 225.8 inches. But that's not really a good measure of how tall the statue is, so let's convert that to feet. So to do that, we would just divide by 12, and that's going to give us 18.8 feet. So then if we want to find how many inches left over we have, we would just take 0.8 times 12, and that gives us 9.6. So the statue is 18 feet, 9.6 inches tall. Okay, that's all I have for today. I will see you in class.